Hi guys, in this video we will look at a very interesting topic, and that is seasonal variation in power, especially depending on the tilt of the roof and the tilt of the panels. How does that affect the energy seasonal variation? So we're going to use this web page here that's called PV Watts. This is free, so it's very nice to use in examples like this because you can go and play with it yourself. There are other very advanced solar analysis technologies available, but they cost a lot of money. But for simple analysis like this, you don't need anything expensive. So I like to use this one because this is something that after watching the video you can actually go and try yourself, and you can put in different data, and you can further your understanding. So PV Watts is a really nice calculator, and you can put in any kind of information, basic information about the configuration that you want to analyze. So in this example, we're just going to use Korat, Nakhon Ratchasima, which is located on around the 15-degree longitude. So we're going to start with the tilting degrees at exactly that angle, corresponding to the longitude, which is considered optimal. Now there are some other factors that we're not going to discuss in this video that complicates things, like temperature and stuff like that. But for pure energy angle tilt wise, 15 is the best in Korat, so we'll use that. And then it's facing south, that's what this means. Now for east-west configuration, everything will change, so we are gonna do it simple. We're gonna look at energy produced with the south-facing direction, which is a very common configuration, and also the most optimal. East and west, there are some very good advantages with that, but we're not going to get into that now. The focus in this video is about seasonal variation. So we'll start analyzing this, and the first thing we can see when we analyze with the 15-degree tilt is that we have more energy especially in March, April, May. May it starts to dip. So we know that the sun is the highest in June. So why is it that it's dropping already in May, June? That's because of the rain season is starting here. So that's why. And then corresponding November, December is lower than the highest. So that's sort of the baseline. And then we can do some differences. We can do, for example, 33. So now we are tilting the panels. So in December, with this kind of tilt, the panels will be tilted towards the sun. That's the easiest way to explain it, because the sun is low in the sky, and then you need a lot of tilt for it to be optimal in relation to the sun. So that's why, relatively speaking, you are getting more energy if you have a steep roof, steep panels in November, December. Relatively speaking, not in terms of absolute result, but you are still higher here. See, so and the relative difference is not enormous, but it's still there. So it's definitely something to have in mind. And then let's do 10 or maybe even 8, just to make it easier to see the differences. So now the panels are more flat. So you get less, because the sun is low, you get less energy from flat panels, because the panels are not angled towards the sun as much anymore. And correspondingly, you get higher result here, because flatter panels help you in this time of the year, relatively speaking. Okay, so we can see from this that Actually, to optimize the production for this time, you would like to have a little bit flatter roof. And this is the time that people use the most air condition. So that's why a flat roof is not bad at all, or close to flat roof is actually quite good because people use a lot of air conditioning in this time. So I would say that is the main conclusion to make, and also that the more flat roof you have, the less production you will have in this time. Is that a problem? No, not really, because you're using less in this time.